All right, hi you guys. I have to remember kind of how to do this since it's been a while. Okay, so this is 6.4. We are going to write partial fraction decompositions, but we're just going to deal with the linear factors for today, and then on Wednesday we're going to deal with, it's more involved, but quadratic factors in the denominator. So partial fraction is part of a fraction. Partial fraction decomposition means, like, when you have a fraction, I will just use a regular fraction right now, like 3/4. We're going to decompose that into two parts. So like 1/2 and 1/4. Now, obviously, there are a ton of different ways to get 3/4, but generally that's what we're going to do. We're just dealing with rational expressions. So, find the partial fraction decomposition of this expression. So we have a numerator and we have a denominator, and what we need to do is we need to set it up into two parts, and we need to find the factors of this denominator. So this is a quadratic, and so I'm going to find two factors that will multiply to x squared minus x minus 12. So I need two numbers that multiply to -12 but add to -1. So we have a -4 and a +3. Okay, so that's going to be my denominators on the decomposed, or the part of the fractions. So we'll set this up. All right, so we're going to have a part plus a part, and the denominator on one of them will be the x minus 4, and the other one will be the x plus 3. Okay. The numerators, we'll just use a and b because capital letters tend to stand for constants, and we're going to have constants in there. So in order to do this, let's pretend we're adding fractions. If we're adding fractions, we have to have the same denominator. In order to get the same denominator, you'd have to multiply this first term, top and bottom, by x plus 3, and this bottom term, top and bottom, by x minus 4. So we're just going to look at the numerator, this part, because we know if we multiplied x minus 4 times x plus 3, we would get this. So we're just looking at the numerator, and I'm going to write it as x minus 25 equals, and then I'm going to take my a and multiply it to x plus 3. So I have a times x plus 3. And then I'm going to do my b multiplied to x minus 4. I'm really going to apologize for my handwriting. I'm trying, kind of. Okay, so let's distribute. So we have ax plus, and I'm just going to write it as 3a plus, and then we'll distribute the b, so we have bx minus 4b. So we have two terms with x in it. So we have an ax and a bx. So what I'm going to do is I'm just going to factor out an x from those two terms. So ax and bx, once I factor out an x, I'm just left with a plus b. And then we have a 3a and a -4b. And those don't have anything common, so I'm just going to tack those on. So if you can visualize this a little bit, we have an x minus 25, and that's multiplied to this x term and this, which will be constants. So a plus b is what's multiplied to x. Well, what's multiplied to x up here is just 1. So it would be fair to say that a plus b has to equal 1. And 3a minus 4b should have to equal negative 25. So I'm going to write that down. Whoops, I meant minus. Whatever. Okay, that's so messy, I can't even handle it. Okay, so now we have a system of equations, okay, that we could put into a matrix and just throw in our calculators and solve it. And of course, you can solve this however you want, but I'll just do this way for now. So 1, 1, 1, that's for 1a plus 1b equals 1. And then 3, negative 4, and negative 25. So you'll put that in your calculator, create a matrix of 2 by 3, and then you're going to probably use the RREF on your second matrix. So create a matrix, then second quit it, then second matrix, go to RREF, and then hit the matrix that you have. Once you get that, you will have your answer here. So you have 1, 0, 0, 1, and these numbers here, I'm just going to look them up, are negative 3 and 4. Okay. Oh, by the way, I have the answer key on Google Classroom so that you can reference that when you're doing your assignment. All right, so this means a equals negative 3 and b equals 4. So what we're going to do is we're going to just maybe erase this a and put in a negative 3. And I'm just going to do this because I don't know if I can actually erase. And then this. So this, excuse me, is my answer. And I promise if you added these fractions together, got the same denominator and added them, you would get this. So I don't know if I said this. I'm only going to do 2 problems because you can pause this and write notes and whatever all you want. I don't know if that'll disappear. Oh, it does. Good. I hope that's what I wrote. Okay, here's a multiple choice. If you want to do it, pause it. But my next click will be the answer. All right, and here's the second part of this first half that we're doing. So this time, if you notice, this is an improper fraction where the numerator is greater than the denominator. So what we need to do is divide out so that we have, I guess, a mixed number in a sense. So what I'm going to do is I'm just going to put that x squared minus x as my divisor. And then my dividend is the negative 2x squared plus 9x. And I'm sure you're groaning because nobody actually wants to do long division, especially with polynomials. But, you know, that's life sometimes. So I wonder if I can get oh, I can get a different color. Yeah. Oh, wait. So how we do this is that first term and this first term, you want to know, you got to think, what can you multiply x squared by to get negative 2x squared? Well, that's just a negative 2. And then I'm going to multiply negative 2 to both of these terms. So I end up with a negative 2x squared. And the negative 2 times negative x is a positive 2x. And then I'm going to, just like in regular long division, I'm going to subtract. So negative 2x squared minus a negative 2x squared is adding, so it's nothing. 9x minus 2x is 7x. Oof. And then I'll bring down that negative 4. So now I have x squared minus x, which cannot go into just a 7x. So we're done. This is the remainder, and I'm just going to write the remainder as plus, and I'll write 7x minus 4 over x squared minus x. Okay, So now what we have is we've decomposed this enough to know that it's going to be equal to -2, and then we're going to have another part. Okay? So we're going to have that A and that B part. Okay? So these two factors, again, we're just going to factor the denominator. Since there's a GCF of x, if I pull out an x, I will again get a different color. So if I take out an x, I'm left with just x minus 1. Okay? So one of my denominators is x, and one of my denominators is x minus 1. Okay. Now we go through the same process, but the only difference is that we're going to use the 7x minus 4. Okay? So actually I'll rewrite this. This top part, that'll be my final answer. But right now I'm just going to go 7x minus 4 over x squared minus x. This is minus equals a over x and b over x minus 1. I don't really like this red. It's really bold and dark. Okay, so we're going to do just like we did before. 7x minus 4 is equal to, and I'm going to multiply a times the x minus 1. And I'm going to multiply the b times x. I will get rid of this color. Okay, I will distribute that a. And then I'll just tack on that bx. My x terms are ax and bx, so I'm going to factor out an x, and I'm left with a plus b. And then I just have a minus a afterwards. So now I'm just going to set it up like I did with the other one. So what's multiplied to x is equal to what's multiplied to x here. So we have a plus b equals 7. And then negative a equals -4. Well, that's nice. If negative a equals -4, that means a equals 4. And b would have to be 3 then, because 3 plus 4 is 7. So all I have to do now is just put in the 3 for the b and the 4 for the a. So this whole big old mess of beautiful colors is your answer. -2 plus 4 over x plus 3 over x minus 1. I'm going to do a quick check and make sure that that is correct. Okay, yep, I'm good. So your assignment is page 402, numbers 2 through 10 evens. The answers are on Google Classroom. Good luck, and if you have questions, I'll be here tomorrow. All right, we'll talk to you later. Have a good day, guys.